which allows the control and monitoring of devices. We have and some standard clients, certainly the command line clients, which we'll go over, which allow you to read and write via channel access. And it also defines the channel access protocol and provides the libraries for the protocol that many other clients use. You know, it's the channel access protocol, I think, that glues a lot of this together. And although we're currently, and today we'll be using EPICS version 7.03, the same channel access protocol will still work, well, certainly my personal experience will work with things back as far as 3.14.6. So the protocol is pretty standard, pretty rock solid. And also, because it's a collaborative thing, there are many third-party items available for EPICS, some quasi-core, and others are kind of on the fringe. I think one of the main third-party components is the ASIN framework, which is used a lot for talking to devices, particularly cameras. It's used in I think it's the motor, some of the motor stacks use the ASIN framework. It's certainly used within area detector, or area detectors builds on top of ASIN, and that provides a standardized framework for talking to cameras and detectors. Excuse me. We have archivers, which allow the storage of PV values and their retrieval at a later date. A very common component, or commonly used component, I should say, is the motor record, which allows, in conjunction with specific drivers for, say, the power brick or the Galil or the GeoBrick and others, provides a standard interface for controlling and monitoring motors. There are many display managers that allow, certainly graphical display managers that allow the displaying and control and monitoring of systems. Three that spring to mind are EDM and MEDM, which are kind of old but still in use, and EPICS QT, which was developed here at Synchrotron. There are alarm handlers. I'll talk a bit about them as well. And alarm handlers are specifically clients that exist to monitor the alarm state of a record or a PV. And again, I'll talk a bit about that later. Another Python over the last decade, I think, has become very popular in the controls world. And PyEPICS is a wrap around the client libraries, and that's used a lot in our facility, and I think in a lot of other facilities. Synapse is not so much a module, but it's a distribution of many modules. And it contains many interesting extra records, or record types, that are used on the beamlines mainly, not on the machine at the synchrotron. And that's just a sample of the things that are out there. And if you go looking, there are many, many more things available that could be useful to you. On the last slide, I have a URL to the EPICS website. And if you go there and you look for things to download, you'll see hundreds of components, things you might find useful and well worth looking at.
I'm just going to jump in here, just to let you all know I'm recording this. I hope everybody's okay with this, and it won't be published to general public. So don't worry.
Have we had any questions?
No questions yet.
Okay. Okay, so that's the basic overview. Let's press on channel access. So channel access is, as I said, the heart of the EPICS. It's the channel access protocol. And it allows channel access clients to communicate with the channel access servers. That's almost a tautology. I've got that in twice. Channel access uses a combination of UDP and TCP. It kind of works out of the box as is, but it's configurable with environment variables. So one of the things you can do is define the network ports or the TCP, UDP ports you're going to use. So you could, in principle, run two independent and non-interacting EPICS control systems on the same network if you wanted to, by defining different ports to be used. What I'm not going to talk about today is PV access, which is a new protocol with structure and introspection. I suppose you could think of it a bit like a binary JSON or a binary XML, where you have data and name, it's tagged, the data's tagged, you can do introspection. All very interesting, but not for today. The key, I suppose the key thing about, well, the main feature of channel, or the main attribute of using channel access is the process variable. And the process variable, and associated with each process variable is a hopefully a unique process variable name that's used to identify the channel. So PV names should be unique, and they're essentially a string of bytes. Channel access makes no interpretation of whether these are UTF, Unicode, or whatever. As far as channel access is concerned, it's a string of bytes terminating in a 0. A client is free to interpret those names however it sees fit. And while the channel access protocol is very flexible with respect to PV names, the EPICS IOC places restrictions on record names, which I'll talk about later, and hence PV names. For an IOC, the PV names are a combination of the record name and the field name, and record names are limited to 60 characters and should consist of the following characters: alphanumerics, underscore, colon, I forgot colon, and hyphen. And I'd recommend they start with a letter. Now, while EPICS is very flexible and currently allows other characters, moves are afoot to generate warnings if you use non-standard characters, and eventually this may become errors. So I would, certainly for new stuff, I'd stick to the alphanumerics and the 3 special characters I mentioned. Just on note, NSLS2 makes use of braces very significantly, and I don't think they're going to change. So maybe they will eventually be included in the allowed set. No, we're good to go? Okay, so channel access has some basic data types. There's about 7 of them. So there's the string, which is up to 39 characters. We have some 3 integers, 8-bit, 16-bit, and 30-bit signed integers. There are no unsigned values in channel access. It has 2 floats, which are the IEEE 32-bit float and 64-bit float, and an enumeration type that can have up to 16 states, and each state has an associated enumeration value, which is up to 25 characters. Channel access can deal with scalars and arrays, but the protocol doesn't really distinguish between a scalar and an array of one element. And in practice, most PVs, I'd say, are scalars. Okay. And along with the channel access data, there's the option of getting a bunch of metadata. And this includes the timestamp, that's UTC, to a nanosecond resolution, together with the alarm severity and alarm status. I'll talk about that a bit now. Each PV can be in one of 4 alarm states, which is no alarm, which means everything's good. It can be in a minor alarm state, which means a sort of warning level. It can be a major alarm state, or it can be invalid. And the status, it provides a qualifier for that. So for example, the minor alarm state might have the qualifier low, indicating that the value is below a certain threshold. most display managers have the option to change the background color or some attribute of PV it's presenting to the user depending on the PV's alarm state. For float types, there's a precision, which is a guidance to display managers how to display floating point numbers, or fixed point numbers, I should say. There's no indication whether it should be displayed as fixed point or floating point. The client just has to know. Numeric types come with units, up to 7 characters, milliamps, amps, volts, whatever. You also get the upper and lower display limits, and this is also a guide to display managers, and that might be useful if you have an analog meter representation. So you could say the voltage goes from 0 to 100 volts. So the GUI could display the meter with limits of 0 to 100. It doesn't actually stop the PV going beyond those limits. Some PVs have control limits, which actually on the actual record will stop you issuing or setting a value outside of those limits, and they're also made available as metadata. Lastly, you also get the alarm limits and the alarm limits and the warning limits. And I'll talk a bit about those later. And finally, you get the enum strings for the enum type. And we'll talk about records fields later, but often these limits or metadata values are defined in a record as a record field. We'll see more of that later. And here is, excuse me, here is a small screenshot of a little GUI I put together just to illustrate the use of. Does the mouse go through? Yeah. Just to illustrate the use of the metadata. So, for example, on these two, you can see they have a pale green background, which in our system means no alarm. You can see this value is displayed with 3 decimal points because the precision was set to 3. The units are milliamps. This is actually a live PV from our system, the storage ring current. This is an enumeration type, so the string or the string value associated with that PV is shut down. Here is another current, and we can see it's got the yellow background indicating it's in the warning limit. And this lower widget is a slider control, and we use the provided warning alarm limits to color the band at the bottom to show which areas are like the good areas, the no alarm areas, this green area here, the warning areas there and there, and the major alarm areas here and here. I should say, when a record goes into an alarm state, it doesn't automatically stop it working. It certainly allows you to present the information, and if you want to take action when a PV is in an alarm state, then you have to be a bit explicit about that. Okay. Channel access. So this is my understanding of essentially what happens with channel access. So when a client wants to connect to a PV, it sends a UDP broadcast who says who has this PV, and hopefully one server says I have it. The client then establishes a TCP circuit to the server, if one doesn't already exist, and then the channel is established. Then the client can perform some or all of the following. The client can request data and the server responds. The client, and this is used very commonly, the client can subscribe for data, in which case the server sends the data and then sends ongoing updates until the client closes the channel. And that's particularly useful for GUIs and the like, or long-running programs where you don't want to keep requesting the data. You just want to say, I'm interested in this PV, give me the data and keep giving me updates. And clients can also write to data. Optionally, when you write to data, you can request a confirmation when the process is complete. If there are multiple PVs out there with the same PV name, certainly the command line tools will give you a message saying there are multiple PVs. EPICS QT will give you a similar message. And from my experience, the channel would connect to the first one that responds and give you an error message for the subsequent ones. So generally, multiple PVs with the same name is a bad thing. And I'm not going to cover it today. If you've got anything like a sizable system, it's worth coming up with some sort of PV naming convention, which will, you may have heard a slight snigger there in the background. People get very passionate about PV names sometimes. I think the most important thing is to have a convention that you adhere to and leads to unique names. Okay, channel access servers. I'll talk about some of the main ones. So the one that comes with EPICS Core is the EPICS IOC, Input-Output Controller. And with an IOC, the PVs are defined by the records that are loaded at runtime. And when we do our exercise, we'll see a couple of those. So we'll go into the detail then. I should say PVs or records can also be channel access clients. And again, we'll talk about that later. Another important server is the EPICS Channel Access Gateway. And these again are both clients and servers. And these allow inter-LAN EPICS communications. So normally when EPICS looks for a PV, it does a UDP broadcast on the local network mask, but they on the local network broadcast address. But typically these don't get passed through network gateways. So the EPICS gateway will, when it sees someone's looking for a PV, it will ask servers it's connected to or potentially knows about on the other network and ask them, do they have the PV? If one of them responds yes, then the gateway can respond, yes, I know about this PV. And you get this sort of double or connection via an intermediate. So as well as allowing connections between networks, the other thing that the gateways can do is allow access control. And certainly on our gateways, we make effectively the PVs you see through a gateway read-only. That's kind of useful. And it stops, for example, in the office network, people can, a non-operational network, people can read PVs, but they can't inadvertently write to them and turn off the machine or something like that. And also, though we don't use it here, there is the scope of renaming PVs. So if you have a name clash or you have PVs on another beamline that you want to look at, but they clash another network, and you have PV names that clash with your own, you can do some rename trickery. Another server is the portable channel access server. And this is a tool that allows people to create channel access servers. I've never used it myself, but it is there. I know there's bindings available to other languages like Python. One of our operators created a channel access server using Python and EPICS a few years ago. Can't say too much about that other than it exists. And there are others like Caproto, which is a native Python implementation that allows, which is itself can be a channel access client and a channel access server. And one of the nice things about Caproto is they have this means to emulate EPICS or traditional EPICS IOC records. So you can actually create an analog input record in Caproto, and it has all the fields available equivalent to an analog record in traditional channel access, traditional EPICS IOC. Any questions? 30. Channel access clients, there's a whole bunch of these, and they broadly fall into these categories. So I think I've talked about them. There's display managers, alarm handlers, archivers, gateways. There's some command line tools and scripts, and the state machines. Probably others as well. So the display managers, there's many of these, but common ones are EDM, the Extensible Display Manager. This is kind of old. I remember my first training course, we used EDM. It's old, but still in use. I think it's still being used at Diamond. I know we still have a few EDM screens to get pulled up at the facility here. MEDM is sort of a similar, I should say about EDM and MEDM, as well as being display managers, they're also the tool that will allow you to edit and maintain your user interface files associated with the EDM and MEDM. So they're both the editor and the display manager rolled into one. MEDM is similar to EDM, it's of a similar age. I don't think there's a lot to choose between them. I know on the beam, at least our existing beam lines, MEDM is used quite a lot as opposed to EDM. Another popular display manager is Control System Studio stroke Phoebus. I know it's Java based. They've done a lot of integration there with things like the Channel Access Finder, the Archiver Appliance Archiver, Beast, integrated with Beast, which is the best ever alarm handler, I think, that they use. So it's quite a comprehensive display manager tool. Another one is CAQTDM, which is Channel Access QT Display Manager. That's from the PSI Institute. And it started off as essentially a clone of MEDM, and literally a clone, so they could take the MEDM UI files, convert them, and then within QT you had something that looked exactly the same. It meant they could take their existing UI files and just use them directly. And I think they've gone on to do lots of things with web applications and the like, but I can't really talk to that. And there's EPICS QT, which is also a QT-based display manager. We're going to use that for our hands-on exercises today. As I said, mainly because I know it best, and just to let you know that EPICS QT was developed at the Australian Synchrotron. I think we started that about 10 years ago now. Any questions come through, Andrew?
Yeah.
Okay. Here is a picture of one of our screens from the machine using EPICS QT. It's just to give you a clue what you can do on the usual sort of thing, labels, buttons. These things here are displaying values from PVs. These are sort of status presentations. They'll go red or green depending whether things are in a good or bad state. Control buttons to turn on and off the power supply. This widget here allows you to enter a number. These display numbers. It's what you'd expect from the display manager. And there's your bonus pop quiz question. If anyone can recognize, have a look at the little logo, and if you know what the answer is, you'll get a bonus, virtual bonus prize.
What's the question?
Yes, but a question.
What's the question? Have a look at the logo?
Yeah, have a look at the logo.
Okay.
We can go back if you want.
Let's see. So there was a question related to the logo, or?
Yes, so if anyone recognizes the logo, where it comes from, they'll get a virtual bonus prize.
All right, get on the chat.
Yes, on the chat. Get on the chat. I'll look at it at the break. Okay. Alarm handlers. So these are GUIs specifically dedicated to monitoring and displaying alarm states. So I think I mentioned before, each PV can be one of 4 or sort of 5 states. It can be in the no alarm state, meaning all is well. Certainly that's either displayed as sort of no color gray or in EPICS QT terms with a greenish background. Things can be in the minor alarm state, sort of sailing close to the wind, but okay, and they're typically displayed with a yellow background. Things can be in the major alarm state, so certainly indicating something's wrong or something's not working or something's off and it should be on, and typically that has a red background color. Things that are invalid or have no meaningful, when things are invalid, it means they have no meaningful values available, or for a PV or a record that hasn't processed yet, it is often flagged as invalid. And they typically has a white background. And at least for the example I'm going to show you, when a PV is disconnected, the alarm handler displays that with a little E. I know EPICS QT will grey out the widget, fade it out if it's disconnected. And examples are alarm handler, ALH. It's old but still used as a synchrotron, though we're developing a new alarm handler called Scram. I don't know when that's going to be available, but we'll find out. And Beast, which is, I don't know who developed that, but that's another popular one, and that's integrated into CSS and Phoebus. And here is a picture of one of our alarm handlers. So it displays the data in a hierarchical format. And you can see inside orbit, this PV is disconnected, and so it flows up the tree. So the storage ring has a disconnected PV, and this flows up the tree, the hierarchy, so you can see the synchrotron has a disconnected PV. So when something happens, the operators can drill down and expand or elide this to find out which PV is causing an issue. And on this alarm handler, if there's guidance available, there's a little G button, you click that and it'll pop up a message saying, well, this error is probably because of some reason. And if there's a P, that will invoke some arbitrary command, which we typically use to open a related display. And entries can have both P and or G, or none at all. And down the bottom, there's some status information. You can silence it for 30 minutes. They can get annoying and shut down because a lot of things go into alarm. And they also keep log files, so that's useful as well. Archivers. So archivers are used to store process variable values in a database for later retrieval. And this is, I think if you're setting up a system, it's well worth getting your archiver up and running early. It's very useful for when things go wrong, you can look in the archive and hopefully get some clue as to what's gone wrong. Excuse me. Examples include the channel access archiver. This is old, but it's still in use, and we ourselves were using it up till about a year ago. It uses a bespoke data file format to store the PV data, and the configuration data is stored in XML files. Another popular archiver is the EPICS channel access archiver. Sorry, the EPICS archiver appliance. This is relatively new, and its aim is to archive millions of PVs. It uses Google protocol buffers to store the PV data and uses a MySQL database to store the configuration data. And it has I think, a really good web interface to the tool. It allows you to view the stats, view data, just if you want to start archiving a PV, you just enter the PV name and say enter and go, and it just works. And we migrated to this about a year ago, as I said. It's definitely a lot quicker than the old channel access archiver. So if you're starting from scratch, I'd definitely look at Archiver Appliance. EPICS QT and other display managers have integrated access to both of these archivers. So if you're looking at a PV, certainly in QT, you're looking at a PV and you want to see what happened, you can just say, if it's been set up correctly, just please give me the history of this PV. Command line tools. These there's a number of these, but I think the most popular ones are CA get, which allows a PV to be read from the command line. There's CA monitor that allows a PV to be monitored. CA put, where we can write to a PV, and CA info that provides details about a PV. And these are kind of useful. They're rock solid, and if you're having issues with a GUI tool or a client or something you just got, you can always use these command line tools to verify your network connection or your IOCs up. They're very useful in that respect. Have we had any questions? Good. And here's a screenshot of me using some of these tools. And we'll use some of these in our exercise as well. So CA get, and then the PV name. So CA get, this is our beam current. It returns with the name and the value. Another one is CA monitor. Give it the name, and then it'll just start printing the times and the values until you tell it to stop with a Control-C to interrupt it. CA put, where you write to a PV. So I tried writing to this PV, and because I wasn't on the machine beam line, machine network, it gave me an error that I can't do this. So I have no write access, so I was denied access. And lastly, CA info. So this gives me information about this PV. So it tells me the host it's on. It tells me that I have read access but no write access. It tells me the data type, which is double, and the element count, which is 1. I should say here, all these commands, you can give the -H option to get help. So they come with lots of options. State machines. I'm not going to talk about state machines in this training course, but EPICS base, or well, in fact, it's not part of EPICS core. It's one of the add-ons. It's the state machine. It's written in a special language called state notation language, and compiled with a special compiler called the state notation compiler. It's based on C with extras. The state notation compiler effectively just converts the SNL to C and then uses the C compiler. Allows you to interact, it's state machine, excuse me. It is a finite state machine. I think it's one of its main advantages, as opposed to a standalone program, is it starts when the host starts and it stops when the IOC stops. Another advantage is, because it's C-like, you can just, in principle, call any C function you like. So if there's some library, you just need to link it in, make use of the functions. Other clients, I think I mentioned EPICS. We've used that quite a bit to do state machine-like things and other functionality. It's popular, in common use. I think it's relatively easy to use, and I think there's great documentation out there on the web for Python. Okay, I'm going to take a couple of minutes to get a glass of water.
Yeah.
Maybe field any questions, and I'll be back in 2 minutes, folks.
Hi, Andres. I might just ask a quick question. Actually, the first one, I don't seem to be able to write anything in the Q&A bit, but anyway, you mentioned that the records can have the units put there. Just curious if you've got a device, say like a current monitor, and it keeps on changing scales and whatnot, is that something that you would normally facilitate through the changing the value of the scale in the record, or the PV which is being broadcast, or is that just something that you keep fixed and you try to get the display manager to do all the work if you want to switch from, you know, nanoamps up to microamps, milliamps and whatnot?
So does this, I think, does this happen automatically by the device, and you have no control over it?
Yeah, so some devices can have that capability. I've seen it on some of the current units, but yeah, just kind of curious.
If it changes without your knowledge, then it's difficult to do anything about it. But if you're aware of it and if you can track it, then you could have a record that keeps an eye on the unit that's coming from the device, and then add some logic to change the engineering unit on the record that's reading the value. I've done that before. It can get a bit confusing when you are archiving, because then when you start reading things back, they're all over the shop, and then you have to keep an eye on the units and stuff like that. So if possible, I would say stick to one unit. Mm-hmm. But if that's not possible because of the way the device operates, then yeah, maybe adding some logic around it.
Yeah.
Does that help?
Yeah, that sounds fine, yeah.
Okay. So, yeah, question about units. Changing units?
Yeah, I think that David's saying that they have some devices that change units throughout their operations, and if you should handle that in the database or in the GUI.
I would definitely the database, I'd say. Maybe even the driver, depending.
Yeah.
Yes, we're not going to, talking drivers and not...
Sorry, I'm gonna Nick.
Okay.
IT.
Oh, careful. Alrighty, okay, let's press on. So the next part will excuse me. We'll talk about accessing the ASCII, which is our infrastructure, basically put together for Beamline users to process their data, but Andreas has kindly set it up so we can use it today for the EPICS training. So I'll go through accessing the ASCII. We'll go through setting up the environment. I should say it's a Linux environment. I hope you're all Linux savvy, but we'll give you a very brief intro to some of the basic commands we might be using. And then we'll go through the exercise of creating an IOC with one record, reading and writing to the value. I've got a pre-prepared UI file that we can use to display and look at it. And I'll talk a bit about the IOC and what's there and the structure and some of the aspects of the IOC. I should say Andres has left for a few minutes and he's monitoring the questions. So if you have any questions, you should maybe hold on. So logging into ASCII, I'll go through the slides and then I'll do it live so you can follow me. This is the URL. I think when I logged in from this machine, I had to accept the security exceptions. So that's up to you whether you want to do that or not. You'll need your username or email as you registered with and the password. For Terry and Matt and other synchrotron folk, I think you just use your regular Ansto email, but your synchrotron password. You click on the I'll show you, there's an icon you click on, it'll launch the environment. It's a CentOS 7 environment using the Mate desktop. We don't have to worry too much about that. And for editing files, we have Vi, Pluma, and Code. So they're the three editors available. I've never used Pluma before, but it's a pretty standard editor and quite easy to use. And I'll be using it in the examples. Okay. So when you go to the website, you'll be presented with the login, credentials. So you enter your email, enter your password, hit sign in. At the top of the screen, you'll see something like this. And towards the bottom of the screen, you'll see, and you might see other stuff. Certainly the synchrotron folk might see other stuff. But what you're looking for is the workshop icon. And you click on that. And when you click on that, it should open this up in a new tab. So this is the desktop. You see here at the top with the yellow box, that's how you open a command line terminal, which we'll be using. And here, perhaps I'll show, on the right-hand side, on the left-hand side, if you click that little triangle there, it expands up and you get something, beg your pardon, you'll see this, and you click on that, it'll go to full screen. Okay, let's go back. For those who aren't Linux savvy, there's a few basic commands we'll be using. There's cd to change directory, so cdx will change to directory X. When you're doing multiple directories, we use / as a separator, unlike Windows that uses a backward slash. If you just use cd on its own, it'll take you to the home directory. That's useful to know. There's ls and lsx, which will list the contents of your current directory or directory X. LL is like list long, gives like ls but gives more details. If you want to type a file, you can go cat X. PWD will print the current directory. I think I said before, you can use Vi, Pluma, or Code X to edit file X, and X will be created if it doesn't exist. There's makedir and rmdir to create and delete a directory, and rmx to delete a file. Okay, some of the basic commands. So once you've logged in, you'll have to start a terminal, and then probably we want to set the screen resolution to suit your laptop or PC, whatever you're using at home. I might have to experiment, but at home I was using 1800 by 1000. Don't try and be clever and set it to something like 18 by 10, because you'll just stuff it up and you'll have to close the session and start again. So I'd say err on the side of too large, then maybe shrink it a bit. And then to set up the environment, we will have to run this command here, which I will go through again, but it's that's about the only thing you have to remember. So data workshop EPICS October 2020 setup.sh. And Linux has auto completion, so well, I'll demonstrate that, but you go data W and tab, and it'll bring up workshop, E tab will bring up this, and so on and so forth. And once we've run this setup command, we'll have to rerun this, or run this command here, and then our environment's set up. And we can check the setup by doing echo this environment variable, and it should output that. And if you get this answer here, or this output here, then we're good.
Sorry.
Okay, so I'm going to run through that live. So I'm going to, what am I doing? Escape. Let's iconize. Oh, that's annoying. Let's let's iconize that. Everyone see that?
Yes.
Yeah, okay, so
Okay, so we have all of the tech support we need to hopefully get you going for this one, almost all of it. So if you have any questions, jump in, and Rosemary and Andreas, if you want to answer them, feel free to unmute yourself.
okay. Oh, not today. So down the bottom here is workshop. Actually, I already had one going, so I'm going to, I wonder if I can close that and show you actually what's going on. So I'm going to delete the session. So I don't know how many you can see, but if you scroll down to the environments, you should see something called workshop. So you click on that, and then this should appear up here. So this is your session. And then you click on this again, it opens a new tab, and here's your session. So the first thing I'm going to do is go full screen. And then I'm going to open up a terminal. Zoom thing's dropping down a pain in the neck. That's the... I don't know if you can see what I did there, but if you do enough of the command and hit tab, it'll complete it. So that's very useful. 1800, 1000. And that's about right for me.
Can I just say that there is also a less terminally way to do this. So if you click on the system on the top left on the bar, yeah, preferences, hardware, displays, yeah, you can pick your resolution from the list on your right. Click apply.
Okay.
If that's easier, maybe.
I like that. Okay.
Give it a configuration.
Let's restore the previous one. Closed. Okay. Well, that's and then the setup. If you well, actually, I'm going to make this a bit bigger because to allow you to see it. So let's go. What?
Control Shift plus.
Yeah, I was going to make the whole thing a little big 8.
Oh, that. Sorry.
Yeah, and then that. Let's go 16. A little better. Let's do. Okay, and as Andreas said, if you can also do Control Shift Plus like a browser and make it even bigger again. So to set up the environment, it was data.
Should we just check if everybody's managed to get in and set their resolution?
Good thinking, yes.
Or if somebody hasn't, speak now.
I'm sorry, I haven't managed to set up an account. I've got all sorts of IT problems. I'm probably too insurmountable at the moment to carry on. So I'll probably fail. I'm sorry about that. It's very interesting.
Sorry to hear that. I think you if you just stick around and still just follow what Andy's doing here, I think.
Yeah, I can just watch on. But something's even crashed my Outlook as well, so I don't know what's going on.
That doesn't sound good.
Apologies.
Sorry to hear that, John.
Okay, cheers.
Okay, so setting up the environment. data, and I think I talked about auto completion. You do DA tab, workshop W, then tab, and then it was EPICS workshop tab, setup.sh. Enter, and it gives you a nice little warning message. It tells you your bash RC has been updated. Now we have to, and it now tells you even what to do is to execute, re-execute your bash RC. And so that is dot squiggle slash dot bash RC. And that's it. If you create a new session or you come back later on, and I should say these sessions will be around for quite a while.
Till Monday midnight, I think, or something like that.
Or the session itself lasts a day to Monday midnight, but the accounts on ASCII will be around for I'm not sure how long. But if you want to come back in the following days and weeks, you can, and this will all be here. Still all be here. Maybe Andreas can jump in and tell us when they're going to disappear, if ever, or when. But certainly they'll be around for quite a while.
He's saying forever.
Oh, okay. They'll be here forever, apparently, until ASCII's decommissioned, whenever that is. But yes, they won't. The point is they won't disappear tonight or tomorrow, so you can come back and play with it over the weekend or whenever. Yes. And what we'll do is, if it's all gone right, you should be able to do echo, EPICS, host. Now, I should say EPICS host arch is an important EPICS environment variable. It's one of the few that isn't set out of the box, and it tells EPICS the architecture you're using or building against. And in our case, we're using Linux 64-bit architecture. So if you all get Linux, if you all do that command, and you see Linux x86-64, then we kind of know we've set up the environment correctly. And I think it's worth waiting to make sure everyone's got that.
Yeah.
Yeah.
Does anyone have an issue running the second command? Oh, well, the second. Yeah, that's the second one. The sourcing of bash RC.
Yeah, mine comes up as access or permission denied.
Did you do the dot in the front?
Yeah.
Yeah, I did the dot at the front.
And you did the tilde slash dot bash RC?
I believe so.
Oh, no. Oh.
I had the same issue before, but I realized it was my syntax wrong. So I corrected them, and it works okay.
Okay. So what was the issue? What was the syntax?
So I put the first dot and the two together. Then it had some issue. So
Okay.
just to double check your syntax.
Yeah, do make sure there's a space there. So has anyone else had an issue, or was that Dave?
That was Dave. Maybe just crack on, and maybe I and Dave can try resolving it.
Yeah. Okay. All righty, we'll crack on. I should say, while we're here, if you use the up and down arrow, you can pull up previous commands. So if you come back tomorrow and you can't remember what ASCII resolution you did, you can just keep going back till you find it. Okay, so we're kind of ready to attempt the first exercise. So I'm going to go back to the slides for now.
Just a quick one. The slides will be available on the website of the events in the timetable section. So you should be able to download them after the session.
Yes, or they are actually available. So all the files we're using are in this EPICS workshop directory. And if you look in there, you'll see there's a folder called slides. You don't have to worry too much about that, but the slides, there's also a copy of the slides in there if you want to have a look at them sometime. Okay. How do I?
All good now.
All right, everyone's good?
Yeah.
Okay, let's go and go back to my slides. Okay, so we've set up the environment. We hopefully got a nice resolution. We can see the EPICS host environment variable. Now we're ready to start the exercise. So the exercise 1. So what we're going to do is we're going to create an EPICS IOC with a single record. We're going to use the make base app command, makebase app.pl command that creates a framework. And then we're going to create a database file with a single record. Then we'll build the IOC. We'll update the st.command file that will load our database. Then we'll start the IOC. And then we'll use the command line tools, have a play with them to read and write values. And then we'll play with QE GUI and actually launch a UI file to look at the PV and go from there. And I'll run through it first. And when we do this exercise, the help and instructions will be available. If you type this command, exercise_1 notes, space 1, and I'm going to do that. So I do exactly the same as you are. It'll bring up a file with some notes on what to do. And that'll probably take us, maybe I'll run through it, and that'll take us almost to the first break.
Yeah, maybe just run through the notes and then we can think about it.
Yeah, and see how it goes, yeah. Alrighty, so escape, iconize. This should open up a file, which hopefully you can read. I'm going to see if I can make it a bit. I'm going to do two things. Edit preferences. I'm going to turn on line numbers so when I talk about a line number you can see it, and I'm going to try and make the, anyone know how to make the fonts bigger? Crap.
Untick, yeah.
Okay, let's see if we can make that a little bigger. Okay, hope that's not done, close. Okay, hope that's not too big, but we'll see how we go. If you, when you run that command, you can bring up the editor and have a look at it itself. So what we're going to do, we're going to go to the home directory. And then the first thing we're going to do is make a folder or a directory for our IOC to live in. I'll half encourage you to, play a bit, experiment a bit. That's half the fun. Maybe if you want to use different names, that's good. But for the actual record name and PV names, if you use the ones I suggest, then if you get stuck, or when we come to use the UI files, at least the UI the UI files I've provided will match the record names that you put in your database. But for the other stuff, I mean, if you want to change names or play with it a bit, do feel free, or just stick to the names I'm suggesting here. So we've made our home, made our directory. I'm going to cd into the directory. And the first command is make base app.pl. And then make base app can do lots of stuff. As most commands, make base app, there's a whole bunch of help and a whole bunch of things we can create. But today we're going to be creating an IOC, but there is other stuff. We can make a support client, we can a CA client, we can do some IOC, Perls, some example, whatever. I haven't really played too much with those, but they are there. And there's so I'm going to do, this is the type. I'm going to create an IOC, and I'm going to call it exercise1. Then I'm going to create the boot directory, which is the same command. So you can see you use the up arrow, -i, and it'll ask you what application you want to use. If I think if there's only one, it will use that by default, but I'm going to put that in. Okay, so that's created a few files, and if you use the tree command, I'll give you an idea of the files that have been created.
You can just go up a little bit?
Yes, I did. So
I will, sorry, can you just scroll up just to the previous command? To where you create the IOC there.
Oh yeah, okay.
I'm putting together, well, I'm typing in the commands in the code pile thing. So I'll share a link with you, so you should be able to see all of the commands and is running. And should be able to copy paste, hopefully.
Yeah, you should. Hopefully, and I have done this. You should, if you really want to type it out, you can copy paste these commands from here to the command line. You can either probably double click or copy, paste. That works. Or you can also do highlight, and you can do middle click.
Oh, nice.
Which is off. I just tend to use that. That's nice. So anyway, this tree is a nice thing. It shows the structure of what's been created. So when we did the make base app, which is now way up there. We did make base app exercise1, and that created this, as well as the configure directory, it created this make base exercise1 app, and it appended the app for us. That's our application, and inside there it created we'll look at this later, some subdirectories. And when we did the make with the -i, this created the IOC boot directory, which again had a subdirectory called IOC1, and which had again some more make files and the st.command file. And again, we'll get to that later. Now, just this whole directory is referred to the IOC's top directory, because it is the top directory of the IOC. And if you look in any of the make files, you will see all the make files at the very beginning have define a variable called top, which points to the top directory, which is, I presume, why it's called the top directory. Okay, so the next step is we're going to cd into this directory here, and we can do 2 directories at a time. if I want to do PWD, just to verify where I am, I can see I'm in user home, exercise 1 app DB. And this is referred to in the vernacular as the big DB directory, because it starts with a capital D. And we'll see later some of the files here get built into another directory with a little uncapitalized DB, and that's often referred to as the little DB directory, just to avoid confusion. And so first thing we're going to do is we're going to create our database file using your favorite available editor. I'm going to use Pluma, and so let's go Pluma, and again I'm going to cheat, or not cheat, I'm going to take the command here, pop it here, enter. Now with Pluma, you don't get a separate window, it just opens up as a separate tab. But you can click between the two and go from there.
Does it need to be called, does it need to have a DB extension?
Yes, that's a good point. These files, there's only certain extensions you can use for database files, and for it's .db, .template, and .substitution. And I don't think we're gonna, might talk, if we have time later on, I can talk about templates and substitution files. But for a database file, the convention is .db. But you can't have any random file extension on these names. It just doesn't work. That's a good point. Okay, so here it is, and again, here is our first database, and I'll talk a bit about what this is. I'm going to copy that into the database, paste, and save that. Okay, so an EPICS database is a I suppose it's structured text. Comments are allowed, introduced by hash, and I definitely encourage you to put comments in. Fortunately, a lot of the databases we get from the community, while functionally great, are sadly lacking in comments telling you what's going on. Not even a comment at the beginning of the file saying this is the file for such and such. So we've got a comment here. This is the exercise 1 database file. It defines a single record, and records are introduced by the keyword record. Some older databases you may come across have G record. I don't tend to see that much these days, but I think it still works. So this is the record. Open bracket, then this let's see if I can, this AI here is the record type, and I'll talk about record types again, but EPICS has numerous record types, and the record type defines what fields are available and the functionality of the record. Now the AI here stands for analog input. Then this part here in quotes is the record name, and I've called it exercise 1 : real. So whatever else you change, for today I'd keep the same name, exercise 1 : real. And PV names are case sensitive, so do keep the same case. That is a colon there. And next, then there's an open brace, and everything between this open brace and this closed brace define the record. And the record is defined in terms of a number of fields. Most fields are optional. In fact, I think every field is optional, and every field comes with a default value. So you could actually declare a record with open brace, closed brace. It would be very useful, but you could do it. So one field that I think is important is the description field, which allows you to provide a description for the record, what it does, what it's about. Certainly encourage you to use that, and certainly EPICS QT, as we'll see, when you hover over a widget on the GUI, not only will it'll tell you its PV name, it also fetches the description, so that can be kind of useful. Another important field is the scan field. And I'll talk about that later in more detail, but this says this record's going to process every 0.2 of a second, or at 5 hertz. We talked about the metadata previously, the engineering units and the precision. So this engineering unit says this record is measuring amps or providing amps or whatever, and it's sensible to provide it with a precision of 2.
I have a question, Andy.
Yes.
How do we add line numbers on the implement?
Oh, okay, yes, very. So if you go edit, preferences, and on the first view tab, there's line numbers. And there you go, that's pretty straightforward. And certainly I've got them on, so I can say on, yeah, let's look at line 8, the engineering units, EGU amps, the precision 2. So we're saying to the display manager, you only need to display this to a precision of 2. And here we are setting up some thresholds. So we're saying we're going into the high state at 10 amps and the high state at 20 amps. I'll talk more about thresholds later, but and we're saying when we go into the high state, we're going into the minor alarm. When we go into the high state, we're going into the major alarm.
Okay, good time to pause.
It is. We're very near 3 minutes up.
Yeah. There was a question on the chat about whether scan value also determines the frequency that the record is being sampled by the archiver.
Yes and no. There's something we'll talk about later is the dead band. But yes, the archiver. Oh, well, maybe you can answer this. But certainly, I'll talk about it later. There's a couple of fields called ADEL and MDEL that many records have, which defines a dead band. And that's to save network traffic and archiver disk usage. If you have a PV that's essentially, let's say, 10 amps, but it's wobbling around 10.001, 10.002, 10.001, 10.002, it's just noise. You might not want to let the operator see that noise, or you maybe don't want to archive that noise. So you can set the dead band in that case, maybe to 0.1. So unless the change is, and in fact it's the cumulative change is bigger than 0.1, it won't send an update to the archiver or a normal client. But if the dead band is 0 or negative, then if the scan is 0.2, i.e. 5 hertz, then an update will be sent to the archiver at 5 hertz. I know the old channel access archiver, you could say, I want to ignore that. I just want to save a value every 10 seconds or every 30 seconds. Can the archiver appliance do the same?
Yeah.
Yeah, okay. So the archivers have the ability to either monitor data and save it as it's received, or you can tell the archivers, regardless of that, I only want to store data every 10 minutes or every hour or whatever. So.
Yeah, so there are a few questions about the field names. If they are standard, if you can add your own.
No.
And what are they? But I think you touched on that in the.
Yeah, touch on that. Yeah, you can't define your own field names. They're defined by the record type. I mean, under the covers in C world, it gets translated to a structure with members. So the fields are the fields.
I mean, I think you can define your own field names if you write your own record.
Yeah, yeah. And if you create your own record, you can define your own field names to do whatever you want.
Or if you modify EPICS base.
Or if you modify EPICS base, yes. Typically, field names are 2, 3, or 4 letters. They can get as short as 1. I don't think there's technically a limit on the maximum length of field name. I think I've seen up to 5, 6, or 7. I know the scan record has a lot of field names, about 1, 2, 3, 4, 5, maybe 5 or 6 but most of the field names, at least for the records from base, are no longer than four characters. And they're invariably uppercase. I don't know if that's conventional or I don't know if it's convention or if it's just the way it is and it's enforced by other underlying structures.
And to get a list of all of the available fields, yeah.
I'll talk about that later.
Okay.
There's a couple of ways. Well, there's 3 ways, but maybe I'll talk about it after the.
Yeah.
Well, I can certainly. I'll say now. There's a URL to the record reference manual, and that will tell you all the fields that are available. In EPICS QT, we have a way of, if you're looking at a PV and you want to know more about it, there's a way of displaying all the fields associated with that PV, assuming it's a PV from an EPICS IOC, which is a record as opposed to some other server. And we'll have a little look at another file which contains all the metadata that the IOC uses. And we won't go into detail, but I'll certainly point out some of the features in that file, and allows you to verify record names and field names.
Okay, let's take a break here and reconvene at 11. If you want to stick around and chat, feel free to unmute yourselves and turn on your cameras. I'm gonna get a coffee.
Me too, but I'll be back.
We'll be back in a few minutes and answer some questions if there are any.
Yes.